Okay, so today, first let's start with some kind of recap and good news. Okay, so this is important. This even odd is extremely important. So the even odd is this is extremely important. Okay, so often using this you can get the answer in one line. Okay, and then we looked at a mnemonic. So using this convention of sin is negative y, cos is positive x, you can get any relation between sine and cos. Any angle changes, plus or minus 90 degrees, plus or minus 180 degrees, you can easily get. That we saw. And these relations, sin A plus B is sin A cos B plus cos A sin B, right? Negative will be negative, and then cos A plus B will be cos A cos B minus sin A sin B. So this is actually 2122 is extremely important because notice one, this is easily derivable from Euler's identity, right? This is easily derivable from that. This goes by the name Euler's identity. And then, I have already boxed them over here, so I'm not, whatever is boxed is kind of extremely important. So I'm not going to do this. Sum and difference, this is the derivation, right? So this, the double angles are easily inferable from this, that we saw. And then we also looked at product to sum. Okay, it turns out this is important. Okay, so ability to do product to sum is important, and then technically, so often you would be needing this because many terms you'll be dealing with products of sines and cosines. Typical way to integrate them is to convert them into terms like this and then integrate. Okay, so this is important. Please remember this. Product to sum is extremely important. Ideally, you want to be able to actively recall. Sorry, not actively recall. You want to be able to recall whenever it's required, typically in the examination. Do a lot of active recall so that you know this one thing. And the good news is, sum to product. I noticed perhaps we are not using this a lot. So is there a net here? Let's do this. We have 4 lesser formulas to memorize. Okay. So sum to product, be aware of it. In fact, how it's derived and all that, but other than that, this is not that useful typically. So that is the good news, first thing. And so here I showed the derivation as well as we have listed down all the formula, right? The box formulas are extremely important. This is already boxed there, so I'm not boxing this. Box formulas are extremely important. Fine. Now we look at integrals of trigonometric functions. Special integrals that show up in engineering a lot. Again, what engineering? This is typically in circuits, signals and systems, measurements, controls. Okay, all of that. In fact, what we did yesterday, that is what we are all this formula is especially useful for what we are going to do today. Okay, we will be applying them. So let's do a quick recall one last time. So sin A is cos B. This is A plus B, A minus B. Sum and difference. Cos A sin B, sum minus difference. Both are signs. Okay. So this we know these terms show up in this, right? That is sin A plus B, sin A minus B formulas. This term show up. So this is fairly easily guessable. That is easily writable. That is one thing. Cos A cos B sin A sin B shows up in the other thing. And we only have a minor surprise with sin A sin B. You have a negative here, right? So quickly notice details in this formula. We are going to recall this specifically. Okay, so let's start with a blank sheet. And I don't know whether this is good news or bad news. Today, there isn't a lot to memorize because if you understand the things, answers are one line, derivable or detectable in one line. Even trigonometric identities, it's like, let's say, 2-3 lines. Integrals, many integrals that we need, the answers are derivable in one line. Okay, you can write down the answers. And this gives you extreme flexibility and saves you a lot of time. Okay, so that is what we are going to do today. And so this is going to be logical. I'm going to use simple properties, but this is going to be logical. Feel free to stop me or pause, ask me to pause if that one line answer is not that clear. Okay, and so there is going to be like 95% logic, 5% memory. Okay, fine. So let's do this. So this is specifically on sinusoidal integral. This is going to be on sinusoidal integral, definite integrals, of course. Okay, and sort of what I'm going to do is like mostly one line. So I'm going to put this as shortcuts, mostly shortcuts, and this is extremely useful in circuits, then measurements, standards, and things like that. Okay, where specifically is this useful? Circuits and measurements. Okay, you will be dealing with things like power and AC circuits, and then average values, average of signal, average power consumed, things like that, average value, RMS values. So those places this is extremely useful. And in SNS, this is going to be extremely useful in Fourier series. So Fourier series, again, our objective is to make many, Fourier series, many aspects, like again, one line answers, one line deducible answers. So Fourier series, and here the actually list goes on and on. Okay, so this is useful in many places, but I'm going to use shortcuts. I'm going to use logical shortcuts of sorts. Again, mostly shortcuts, mostly logical of sorts. So let's get started with simplest of them. Okay, integral 0 to t 90. This is, anyone guess this value? So t is a time period. Okay, so what follows? T is corresponding time period. If I integrate sine t over a full time period, what do you get? Okay, let's see what this function is. We are doing it over one full time period. So the function sine t is this. Let's put some landmark numbers. So you have a 0 here. So this is going to be your t axis. This function is now sine t. Okay. This is going to be pi. This is 2 pi. So after 2 pi, it's going to keep repeating. All right. The function kind of repeats. This is periodic. The period is 2 pi. Hey, this is a definite integral, 0 to t. I'm not asking an indefinite integral. I'm asking a indefinite integral. So in this case, the time period t is going to be this. This is a period t here. By integrated over a time period, what do we get? COT. Let's see who cracks it first. Most of you are answering this indefinite integrals, cos t, integral of sine is cos t. That we know. So that you're going to get it if we do integral sine t. So cos t minus cos t plus c, right? But what I want is 0 to t in t dt. We have our 0 here, our t here. I can also zoom this because graphically this is partly, if I integrate this from 0 to t, what do you get? Great. So now Harshita kind of broke the ice. Notice positive area. It will exactly cancel with a negative area. Cos t minus 1. So if you substitute t, cos t is full time period. Here t is 2 pi. What do you get? You are actually doing, okay, definite integrals only. So cos t is full time period. If you substitute it, notice you are going to get a 0. The positive and negative areas cancel. So we have 0. A 0. This is important because notice the way that we are answering is A, the two areas cancel. Right? Let me also leave a hint there. That's your proof. And notice so also pay attention to how I have defined the time period. So T is time period, corresponding time period. That is, if I think of a sinusoid with a different frequency, different angular frequency, any of that. So I'm referring to that time period. Okay. So time period keeps changing if I am talking about faster and slower sinusoidals. That kind of helps. Okay. So now let's do this. In fact, notice here, here I should technically put, so notice your t happens to be note your t happens to be 2 pi. Present in this page. 0 to 2 pi sine t dt is 0. Now, color did I use? Let's stick to the same colors. No, let's differentiate. Hello, t sine omega naught t dt equals what? T, what is t? T is corresponding time period. Definition is this. Zero. Harshita is again fast here. The story is the same. Just okay. What is the t exactly here? We'll look at it. This omega naught is not that important. Let me put it as omega. Okay. If I draw this, how will the function look? Again, it's going to be like this. And it's going to be like that. Your sinusoid. Okay. So, but the values are going to be different. So, for example, this is 0 as usual. Anyone tell me what is going to be this point here? What is going to be this point? So that point is going to be t, the time period t. So now what is the time period t? So you can look at this input. When omega is when omega is like this. Notice 2 pi by t. Okay. What goes inside that bracket, that is the input. Input is a whole number. Two pi. Right? So that is, notice, so the input specifically will be omega t will be 2 pi by t into t. That is, when your time is actually exactly equal to t, this t by t is 1. Omega t will be 2 pi, so you get a 0 there. That is one way to look at it. I repeat that, that's an important point, so let me repeat that again. Okay. There are two ways to look at this. One, so when omega t is 2 pi by t, notice input is t by t into 2 pi. This is your input. Omega t. This term is your omega. This is your omega. But notice at this stage, so this is a fraction. Fraction becomes 1. The input on this is a fraction. You know, less than t. When exactly it touches t, this becomes 1. input will be 2 pi. So sine 2 pi will be a 0. That is one way to look at it. This is a preferred way. Okay. For fraction, so technically this should also be, technically 0. This. So bottom bottom line, this is an important relation. Your omega, this is going to be 2 pi t. Omega equals, okay, 2 pi by t. Whenever your time is exactly equal to t, you get here. Of course, this axis is your time axis. That axis is your time axis. So, this is the story. This integral is also 0. Why? Same reason as before. This answers this. You got it and you wrote on the answer. And let's look at that second way to look at this. As I said, omega is 2 pi by t. This actually corresponds to distance by time. The angular distance it travels in one time period is 2 pi, right? So what is the speed? Angular speed, it travels 2 pi distance in a time period of t. 2 pi radians in a time period of t. If it is oscillating, it travels 2 pi radians in a time period of t. So you could say this is actually angular distance in radians. This is by time. This is 2 pi by t. This is also another way to look at it. This is also useful at some places. 2 pi by t. So based on this interpretation, we'll call this the angular speed. Angular speed. Okay. Getting the crux integral of sine, full time period is 0. You change the frequency. Notice this point is not 2 pi. This point is not 2 pi. It is t. It's a time period, full time period. So this is when it starts repeating. This is 0. Let's do a quick set of questions. So integral 0 to t, 90. Hey, there is a dt there, okay? Whenever I put an integral, I don't put that dt. Yeah, so this is 0. Integral 0 to sine omega t dt 0. Technically, so I am referring to of t omega. Where what is that relation? Let's also write the no notice your omega is 2 pi by t. Right? Pi by t omega to be consistent. Now minus t by 2, t by 2. Actually, you don't need minus t by 2 to t by 2. Let's do 0 to t cos t dt. Cos t dt. Which is this? The first question. Great. This is 0. 0 to t. Again, if any of you are wondering. Cos function. So that's your positive area. It's your negative area. They will exactly cancel. That's your cos function. Cos omega t, of course, you will have to put a t omega t. How much is this? This is 0. Again, what is it omega? Notice your omega is 2 pi by t subscript omega. Because I'm trying to differentiate this omega. All right. Now comes the interesting question. Integral 0 to t omega. Pay careful attention. Sine. So even before I write the question, now I am hearing zeros. So I'm going to change the question. Right. So now what I want is, so the answer is going to be 0. I need an explanation. N omega much is this? I didn't take omega t. Or notice. So what I mean is, but omega is 2 pi by tw. So this is not nw, tnw. That time period and this time period is different. N is an integer. Okay. Let's clearly write it down. Integer n. Teacher n and tw or 2 pi by omega, or omega is t 2 pi by tw. So it's not the period of this, which is what sin n pi is 0. Great. Now Harshita says, so this is 0. I answered it because now there's a repeating function. Repeats t. Reason as periodic function. Right? This is a faster periodic function. By 2 pi n 1 minus 2 cos 2 pi n cos 2 pi n. No. It's not. Again, I'll try to draw this as accurately as possible. We're talking about sine, right? This function is sine omega t. would sine 2n omega t look? I do agree with kind of partly with Harshita's answer, but you need to be somewhat careful, okay? Because some kind of specific type of mistake is possible here. Let me explain it here. Now, what is sine 2 omega t? So let's also draw some referral lines. So this is a period t, right? So this is your t omega. That's your omega. Oh, twice as fast. This is sine 2 omega t. It is twice as fast as the original one. You can kind of afford to look at just one period. When it repeats once, this is repeating twice. This is your sine n omega t. So this will also cancel. Great, yeah. Now this will also cancel. Positive lobes, that will cancel with negative lobes. Notice just to point out. So notice this period t2 omega. Okay, should be this. This should be equal to this as a frequency. This will be pi by 2 omega. The frequency will be like now twice. Okay, time period will be half. Time period is halved. Frequency is this is a subscript. Subscript. Okay. Now this is again 2 pi by omega, but it's going to be half of that. Period is now halved, but things again cancel out. We are not actually talking about this function repeating. The reason I pointed out now. So 0 to nt, that is also 0, because the way at least it's worded, you're all giving concise answer. Sine n pi is 0. Okay, that explanation fits this integral 0 to nt, but 0 to t. If you do sine n omega t, it goes to 0 because again the function repeats. N is integer. Number of lobes increase, but they all match. Positive and negatives matches. With 3, you'll have 3 positive lobes, 3 negative lobes. N positive lobes, n negative lobes. What happened there? Again, let's kind of that was cancelling with this. Great. So this is 0. This is 0. That is 0. From 0 we have. So RHS is 0. LHS is like now looks complicated. Okay. So now this quick question. Questions. So to t. So t omega cos n omega t. How much is this? 0 to t. 0 to n t omega sine n omega t. This is a subscript, so I'll try to make it look like a subscript as much as possible. How much is this? How much is this? I have two questions. What will happen with the cos? Come on, what is this? In fact, the bottom one I just answered. First is 0. Because same logic, no? As far as it's a full period, it doesn't matter where you start. You could technically start here. Okay, if you start there, you'll have like things exactly cancelling. Right? The positive lobe will cancel the bottom lobe. So as far as it's one full period, it will cancel. So it doesn't have to be 0 to t. One full period is what we technically were referring to. How about the second one? Second is also 0. Now this is the multiple repetitions because now sine n2 pi is 0. This add more here, things will get cancelled. Two complete periods, they will cancel, right? So we are referring to that. Yeah, be careful. We have a n here and we have a n here. Now slightly let's spice it up. So this is actually not one line. We are writing down the answer. This is like question and answer. There is no question line answer, question derivation answer. This is like right now question and answer. So we have to make it at least one line. You could technically see it in one line, but let's still explanation might need longer. So this time there is this bit. Let's do integral. So I have kind of prepped you enough for this. Integral 0 to t omega sine of n omega t. This is a bit confusing. Let's make n1 to start with. And you have a cos omega t. How much is this? Need an answer with explanation. Brief explanation is like of words, maximum one sentence. Sine omega t cos omega t. Come on. What the problem is, we have a product. You know how to convert a product into a summation, because so far you are very good at handling sinusoids and cosines. So split the integral into summations. That's it. That's a strategy. If you are like wondering, I told you all the formulas yesterday. Split it, you should get the answer in one line, or even otherwise, here you could see it slightly differently. Sine cos. Shraddha kind of spotted. 0. Oh, this also 0, is it? So now there are two explanations. Explanation 1. Sine omega t cos omega t equals half of sine 2 omega t. So what is inside the integral is just another sinusoidal. We don't have something new. Sine 2 theta is 2 sine theta cos theta. That is what I have written here. And all this explanation holds good even if there is a n there. So sine n omega t is repeats at tw. Still periodicity, it's a faster function, but still it goes to 0. Yeah, in a full cycle it will provide 0. Yeah, now most of you saw that, right? That's also let's also run with tw is 2 pi by omega. This is a subscript. So now if you put it tw is 2 pi by omega, so tomorrow someone will come and say, sir, t is 2 pi by omega square. Omega is square root of 2 pi by t. Now you will get into all sorts of trouble, right? So this is a subscript. I am repeating it many times. Let's also look at explanation 2. Explanation 2. Okay. This is sine of n omega t cos of n omega t equals half of sin cos. What is this? Sine. Sine of 2n omega t a plus b plus sine of a minus b. Where I specifically used this relation, let me also write it down for everyone. Sine a cos b half of sine a plus b sine a minus b. This is what we read yesterday. Great. So this also tamed. This was easier to take. Let's take this. I've given you the necessary primer. Let's modify that. Integral 0 to integral 0 to omega. Color code it. No color coding this time. Okay. Sine of n omega t cos of m omega t. Hey, n is an integer. Okay. Integer n. Integer n. One and integers. What would be this? Hey, no. This is, I'm asking what the right hand side is. Sorry. What is this? Let's put a question mark. Let's see who answers this. Be careful. But t omega is 2 pi by omega. And nm integer and nm. Who wants to answer this? What should that be? So this is integral half n plus m omega t. The final answer. It will simplify drastically. I can actually help you with some, but this actually depends on relation between n and m. When n equals to m, and this is something. When n not equals m, this will be something. I'll give you that much hint. N equals to m, this is not a big deal. This is 0. Fine. When not equals to m, what would it be? Mukta got it. That's going to be t by 2. T omega by 2. Time period by 2. Why? This is going to be, let's write it here. Reason sine n omega t plus, sorry, not plus. We are going to product into a summation form. Cos of m omega t, okay, equals half of, this is sine n plus m omega t sine n minus m omega t. Okay, now is this changing based on both are sines, I suppose, right? Yeah, both are sines. Equals m, one term easily goes to 0. Sine and cos. There should be sine a plus b, sine a minus b. Where is the cos coming from, Mugdha? Sine a sine b. That is half of sine a plus b plus sine a minus b. Right? Also open up the notes that I sent. What do we have it there? So technically, actually this is, I have to go slightly make a correction. Notice this is both integrals are 0. So technically there is no distinction here. Either n equals m or n not equals m. There is no distinction. It's both 0. Is it 0? So the answer is 0. Okay. There's no special case here because this is just summation of two sinusoids at the end of the day. And term goes to, with two sinusoids, you'll never get a 1. Cosine you will get a 1. With sinusoids you will never get a 1. Both integrals go to 0. Both integrals go to 0 perspective of n equals m naught. Okay, so now, so this is all so far only zeros. Fine, at least, the question is this term, can this term, what happens? We are starting to see that. That's good. So let's write one more integral. So we did a sine and a cos. In fact, so let me write down the conclusion. You could have spotted it other way around. Okay. Vector I is perpendicular to vector J. That is, we'll say, I write this with bit of clarity. Vector I direction, this is perpendicular to J direction. Right? Vectors, this is what we call as orthogonal vectors. So what that integral says is, I have boxed something, right? what that box says is, in fact, that needs to be given special special highlight. Box says sinusoids and cosines are orthogonal functions. Similarly, make it relatable. I am making analogous because start with ing. Ing are two functions. Sorry, two vectors. Perpendicularity can also be used for two functions. Relation between two functions. Okay, so is there a dot product between two functions? Yes, there is a dot product between two functions. In fact, what you are staring at it as a dot product. Okay, I'll come to that story a little later because that picture is quite helpful. So similarly, sine sine n omega x and cos m omega x for, of course, integer m, okay, or orthogonal functions. That is, they are perpendicular. So the dot product, integral is a dot product, the integral will always be 0. Orthogonal functions. So this is why I could have, in fact, I wouldn't even have, for this example, I wouldn't even have gone for this step derivation. Hey, these two are perpendicular. And this is one of them. If you stick to engineering, if you learn applied mathematics, what I have shown written there is actually extremely important. We'll come back again and again. Okay, just like I and J are perpendicular vectors, that integral becoming 0 tells you sine and cos are orthogonal perpendicular functions. Let me write it in that style. Again, I need 10 more minutes, okay, because we'll complete at least half of what I prepared. Because they are orthogonal functions. This is extremely useful, very useful. We'll come back to the relation between dot product and integrals little later, okay? But you know the reason. That is just I gave a simple English. So let's do 2 more integrals and then we'll wind up. So same story. What would be this? 0 to time period cos n omega t cos m omega t dt. And here, let me give you, you would need a condition. It will depend on n equals m or not. This is n equals m, you will get a result. And then n not equals m, you will get a result. Cos. What is cos? Cos is cos a plus b plus cos a minus b. I need 2 answers technically, so it depends on the value of n. What is this value? What is this value? Tell me, when n equals m, it is this. When n not equals m, it's this. And from a recall perspective, this is fairly simple. First time derivation, this is going to be hard. Okay, now n equals m. N equals m is the same function. It's cos square. That will be 1 minus cos 2 theta. Be careful. When n equals m, you have to be careful. Okay. When n is not equal to m, I think the answer is fairly simple in this case. Going to be a 0. Because these two functions are perpendicular. Any cosine is perpendicular to any other function. These are nice orthogonal bases. Nice functions to represent other functions. Okay. You have to be careful when n equals m. N not equals to m, it's a 0. And when n equals m, this is going to be, from a recall perspective, this is going to be fairly simple. T W by 2. Half the time period. That's it. Let me show you the derivation. So at this stage, let me show you the, write down the derivation. Okay. Cos n omega t cos m omega t is going to be half of cos a plus b cos a minus b. Right? So cos m plus n omega t plus cos minus m omega t. Minus m omega t. So we have answered this. Answered this. We know what happens to full period integration of cosines. That is also 0, but you have to be careful here. So always 0 integrated. Here equals 1 n equals m. When is equals 1, this is cos 0, that is 1. So it equals 1. So this is the term inside the integral is 1 by 2. If you integrate 1 by 2 from 0 to t, you'll get t by 2. Right? You are integrating a constant, so just the limit will show t minus 0 by 2, t by 2. So it is a 1 under a very, very special case. So that gives a 0. Okay? But from a recall perspective, cos is time period by 2. That's it. Okay? If you want, you could go substitute this. You could, substitute this, write it into two integrals and see, hey, this integral is always 0. This integral, hey, this term becomes a constant, right? You could do that. I'm just looking at the integrand. I'm looking at this and making a call. Okay. Because I have reasonably simplified it for you till now. So one last thing and we'll wind up. So we did cos. Sin cos is going to be always 0. They are perpendicular. And so notice, so there is something to notice. Cos n omega t and cos omega t or orthogonal, perpendicular, or not equals to m. Okay, again, that's an important detail. So let's do the last integral for the day. We did a cos 0 to t, same old story. We'll do a sin n omega t. Sin cos is 0. Sin m omega t equals what? Again, this should depend on two things. When you have a n equals m, and then when you have a n not equals m. To answer this, we'll wind up so justification is going to be the same as this. Sin will be cos a minus b minus cos a plus b. All right, sin. Let's put a question mark. We'll answer this wind up. Okay, won't justify this. Technically, you should have got an answer by now. Notice sin omega t sin a sin b equals half cos a minus b plus cos a plus b. Again, when n equals 1, this term becomes a 1 when n equals m. Otherwise, both are cosines, they will integrate to 0. Answer? Special case of when n equals 1, there is a constant here. So when I integrate a constant half, you'll get half into t minus 0. So t w by 2, you get a 0 in this case. Only when n equals m, thus cos a minus b will be 1. In cases, two cosines, they will just disappear upon integration. Fine. Waiting for an answer, but let me fill it up. At least, it helps if you, from a recall perspective, if you know the result, it helps. Also notice, let me also minor comment notice. So sines, this is actually very nice basis. This is the beginning of Fourier transform. Why do we represent its sinusoids and physics? Because it gives you a perpendicular basis to represent functions. Okay, so sin omega t and sin m omega t or perpendicular, that is orthogonal for not equal to. So bottom line, all the integrals we saw today, they are all 0 except for two cases. All full time period integrals, all of them are 0. Any sine cos is 0. Okay, and not any sine cos technically, so this is important. Okay, and then cos is t by 2 if n equals m, otherwise it's a 0. Sine is also t by 2 if n equals m, otherwise it's a 0. And the condition is important, so let me write it as, so where t by t omega is omega by, 2 pi by omega, and integer n and m. Okay, sounds good. Only two non-zero integrals. The whole of this. Even if you don't remember them, arriving at them is max one line. You have to use a product to sum formula. If you use it, you will see the result in one line. You're not convinced about, say, this reasoning or any of that, do it, get yourself convinced. Okay. And yeah, so next class we'll apply this. We'll apply this to a couple of places. So we'll apply this to average values, RMS values. If possible, time permitting, we'll also apply this to Fourier series. Okay, that is the objective. For now, let's stop. Any other questions? Okay, if no other questions, looks like hey, there is some Demon Slayer movie or something like that is out. So I have to go get a ticket. So I'll have to stop this, even if there are questions. Okay, put it in the group if there are doubts or anything like that, and I'll follow. Okay, have a good one. Take care. Bye. I'll see you again.